NetBeans. It'll take about a year to start up, but after it does, this is what you'll see. I may have a pretty old version of NetBeans, but we should essentially be on the same page. Now, what you want to do is start a new project. Now, every Java application is wrapped in a project, and to start a new project in NetBeans, you hit File, New Project, and you choose Java Application and hit Next. Once there, you want to give your project a name. Now, our project that we're working on right now is the Magic8Ball app, so we're going to put that name in, Magic. Now, keep in mind that you can't put spaces in your project name. Rather, you can't put spaces in your project name, but it's better to leave the spaces out, as you'll see here, because there are other things that are generated from the project name that really doesn't tolerate spaces. Hit Finish. And what the IDE does is it generates a lot of code for you, and so this is just an example of some of the code that it generates. Also, you can right click and explore the IDE a bit more. You can insert more code, do a few other things with the IDE. So the point of the IDE is to make your development experience pretty straightforward and effortless. So your project is displayed, or should be displayed, in the Projects tab on the left, and we see our Magic8Ball app here. The source would be in our source packages under this Magic8Ball app package itself. Now, a bit on packages. The package in Java, you can think of it right now as just a simple folder that holds your source file. Right now it holds the Magic8BallApp.class file, which is the source file that we're currently looking at. What packages do is that they allow you to neatly organize source files, especially when you're building an API that's being reused in other software systems. And they can be nested, so you can have a number of sub-packages within the package folder and so on and so forth. When you interact with the Java API, you're going to be interacting, you're going to be going through a lot of packages to get to actual classes, and you'll see that happen in a bit. But for now, just think of a package as a folder that contains your class file, and it neatly organizes it in that regard. So what we're going to do is we're going to create a few other classes in addition to this driver class that has our main method that's generated for you. We're going to leave that alone for now. We right click on the Magic8Ball app package icon. We go to new, and then we hit Java class. Now we'll get this dialog that shows up, and the first class that we're going to create is our new Randomizer class. Alright, so we just type in Randomizer as the name of the class. Again, point to note, class names should not have spaces. They always begin with a capital letter, and they use the camel case approach in terms of naming. Now, what camel case is, it's just like Magic8BallApp in that all of the words that are in this entire name have leading capital letters that sort of look like humps, hence the name. So we hit Finish, and this is all we get. But our randomizer class is pretty simple anyway, so we're going to finish this in a few lines. So remember, private array list string responses. Alright, so that's the declaration. Now you're going to notice that it's going to underline stuff and go crazy and alert us, but don't worry, the IDE takes care of automatic cleanup and automatic imports. Now it's complaining about the array list not being found, but it does know that it may exist in the documentation, so we can optionally just click on this right now. left click on it, and you'll see a few options, among which is the add import for this class. Now, like I mentioned earlier, we're going to be accessing packages to find classes, and the whole Java API itself is built on packages. A lot of packages are used to organize the classes within the API. Java is a package here. Inside of Java there's a util package, and inside of the util package there's the ArrayList class. Alright, so you're going to see this formation happen a lot. Alright, so back here, so we said that the ArrayList in class, we said that the ArrayList is a very useful structure when compared to the primitive array, because it automatically resizes, and it also has optimizations built in out of the box, and it has a number of utility methods to do a variety of things like retrieving, setting, removing, and even sorting, organizing, shuffling, and a variety of other things that we can use right out of the box without having to write the code from scratch. So that's a bit about the ArrayList. Now we're going to proceed by creating our constructors. So remember, it's public and in class name. Alright, and inside of our constructor we're going to instantiate our responses variable, or rather I should say a responses object, which is of type ArrayList with string data types. So we do it like this: responses equals new. Remember, the new keyword is used to instantiate objects based on the class definition, and whenever new keyword is run, it actually calls the constructor of the class, and the constructor is designed to build that class into an object. Right, responses. Okay, sometimes you may have these inconsistencies in spelling. The IDE helps to identify these inconsistencies, but you also need to be very keen in terms of your debugging, just to make sure that you don't make these mistakes and go crazy trying to figure out why the program doesn't compile. Always check the naming first. Make sure all of your references are named consistently and correctly. That helps. So we set up the ArrayList. At this point, responses is an active object that represents an empty structure with the ArrayList class definition, and we're going to populate it with some things like responses. Yes. So remember, this would just be a number of, there I go again, responses. Okay, this would be a number of random responses, and point to note is that you're going to be using copy and paste quite a lot in coding if you haven't already realized that. No. Looks bleak. It is decidedly so. Ask again later. When hell freezes over. Okay, so we'll stop there, but you get the idea. You can add as many other responses as you wish. I think there are about 20 responses in a typical real-world Magic 8-Ball. And we've just added 6. So right now what we're going to do is we're going to proceed to write our behavior into this randomizer class, and we said the behavior is represented as methods of a class. In this case, this class only has one method, which is get random responses, and it looks something like this. Get random responses. Great. Now, what this method should do is return a random response. Okay. And we discussed in class that there are a few ways to do this, but one of the cleanest ways to do this is to leverage the API and all of the utility methods that come with the array list structure, which is what Java calls a collection. Alright? All of its data structures in Java, they call them collections. So what we're going to do is we're going to use the shuffle utility method on a collections class. Alright? And we'll get into static classes a bit later. And what this collections.shuffle allows us to do is it allows us to shuffle a particular data structure, which Java calls a collection. An array list is one of them. But there are other structures that can be shuffled just the same way by calling it the way we're calling it here. Now what I'm going to do here is I'm going to fix this import. Alright? And when I do that, the reason why I'm going to do that is I'm going to let's see, add the responses in there, right? And we can imagine that after this line executes, the responses that are added in this particular sequence will no longer be in that sequence. For instance, this item may be at the top, this item may be at the bottom, and so on and so forth. So this execution, this line here, really mixes everything up for us. And what we typically do after that is return. We call the return statement just like in C, but we do something like this. Responses.get, and we just hit 0 just to grab the first item off the top and return it. So these two lines essentially accomplish this, just returning a random response from the collection itself. And the randomizer class is finished. Alright, so we're going to get started on our UI class. So we go to new, create new Java class, and we're going to call it 8ball frame. I think that was the name we used in class. And we said that we would actually build upon the JFrame class, which paints a visual frame, an application window, whenever the application is run. So we don't have to write the code to actually paint an application window. We just build upon code that's already there that does that. And we use the extends keyword to do that. JFrame. Alright, so let's fix imports. Another way you can fix imports, especially multiple issues with imports, is by right-clicking whatever it is that has an issue, and we hit fix imports. And it does everything within the source file. Fixes everything within the source file. So inside of this, we said that it contains a few attributes. The first of which is the display. And we said the display would be of type JTextArea. So it would be a JTextArea, a text area component, but we don't have to create a class for that. We're just reusing it from the API that's already available to us. Alright. Display. And another class that we're going to declare is our Randomizer class. Alright, and we get started on our constructor. And inside of a constructor, that's where all the magic happens to build this object. And that's where we instantiate all of our internal objects, give them values if possible, configure them. Particularly in this case, since this is a UI based class, we're going to be setting up the UI, we're going to be adding a button, we're going to be adding some code to have the button respond to a click, just like the on click in JavaScript, if you remember. So we're going to be doing a lot of setup coding inside of a constructor, and that's really what the purpose of a constructor is, to contain all the code to construct the object. Alright, so let's get started. So we're going to first instantiate the display. Alright, then we're going to instantiate our randomizer. Then we're going to add a button. Alright. And we're going to continue to build the UI, but I want to take you through it in stages because it's quite a lot to take in right now, especially learning Java itself. Alright, so in class you saw the add method. Okay, now the add method is used to throw components onto the blank visible area of a frame. Now, before we get into the add method, what I'd like to show you is that blank visible frame. Alright, so what I'm going to do now is I'm going to put enough code in and then compile it and then run it so that you see the frame as it is before we add any components to it. But keep in mind, behind the scenes, somewhere off floating in memory, our display is alive, but it's just not added to the frame, so it won't be displayed. Our randomizer is alive and our button is alive. Keep this in mind and just follow me as I go through here. So the code that I'm going to add here to get this frame to be displayed to the user, it's just a bunch of initialization code for the JFrame itself, and since this class extends JFrame, we need to write that initialization code. We need to set values to those bits ourselves as well. So the code that I'm talking about would be the set size. Alright, and that just allows you to specify the dimensions of the window. And then we have the set visible. This shows it, this actually displays it to the user. And there are some other things that we can add, but we won't necessarily add those just yet. So right now we're going to right click and then we're going to fix imports, so everything, all the alerts go away. We're going to save that, and this class as it is can be compiled, and it would show up. But the last bit to make everything work is to instantiate this class, and we're going to do that in our entry point class, which is this, our driver class. And just like in class, we're going to put new 8-ball frame, right? So it's going to give an alert there, but that's okay. So let's try to run this and see what happens. button every single time we need to run an app, and it automatically compiles it for us, and this is what we see so far. Now this shows up because we haven't really done anything much to the 8-ball frame class just yet. All we did is we extended the JFrame class and we set the size of it to 5x4 and we set it to visible, and this is all we get. So you can imagine that what you're seeing here is more or less the raw JFrame with some added settings that we've put in terms of its dimension and its visibility, but we need to do more than that. You'll also notice that it comes complete with maximize buttons and minimize buttons. All of those things are built inside of the JFrame. We don't have to worry about building code or writing code to do these things. Even a close is available, but a close doesn't actually terminate the application, but I'll show you some code later that you can use to terminate the application. You may have to manually make sure that you manually click it off until you write that code in. Alright, so this is how you do it. You just click on that X and it terminates it. Alright, so let's continue with the UI here. We're going to add some stuff to that blank area that you just saw. The first of which would be our display, but we have to do it in an elegant fashion. We need to make sure that the text area, as well as the text area which we call the display, as well as the button which we call button, the J button which we call button, fit neatly inside of that display area. And that's getting into the realm of layout policies, but I'm going to try to keep it very simple for you. So you saw the add method. Alright, the add method allowed you to add components. It allows you to add components to that blank area. Do keep in mind that unless components are explicitly added using the add method, they will not show up in the frame. So that's what I wanted to demonstrate by just running it as is without adding. We've created them, but we haven't added them. So now we're going to add them and then run it again and see what happens. So we're going to add the display first, and we're going to use another version of the add method that allows you to specify where you'd like this item to be displayed, or how much space you'd like this item to take up within the area. And this is done through another class called border layout, for instance, and it's a type of layout class, and it allows you to specify quick layout arrangements. So we want the text area to display, take up the most amount of space in the window. So we use border layout at center. Excuse me. And then we add our button, and we'd like our button to be displayed just below the text area, not taking up as much space. So we use border layout dot south. Okay, so we put these two lines of code in, and what I'm going to do is I'm going to clean and build it again just by right clicking and clicking on that option, and then I'm going to run it. And what you have is your text area. You can definitely type in the text area if you wish, because we haven't set it to uneditable rather. And then there's our button there, and we can click on it. So you've just witnessed the first UI in Java being built by just those couple of lines. Alright, so let's proceed with the functionality. I'm going to leave the UI as basic as you saw it there. I do encourage you to explore a bit further. You can add more enhancements. The API documentation is available, so I urge you to browse that a bit, see what more you can do with the UI, make it a bit fancier. You can even add images of an actual Magic 8-ball if you wish, just to make it a bit more let's see, aesthetic. Alright, so we're going to leave this constructor as it is for now, and we are going to proceed with our behavior. Now the behavior here is just public handle shake. Void rather, public void handle shake. Because it doesn't return anything. And our handle shake method here is activated whenever the user would click on that button. And it would handle the shake. It will handle the shake by first it'll first get a random response from the randomizer and set response to display. So let's try to fulfill the first requirement, get random response from randomizer. Just like in class, we set up a simple temp variable, and we use the reference to the randomizer class, which is randomizer with a common R. Alright? And we ask randomizer, okay, well, I need to access one of your methods. And here you'll get the first insight into the IDE's IntelliSense, so to speak. And you'll see that the class is already inspected by the IDE, so it knows, the IDE knows what the class is able to offer you, and it lists it. What we're particularly looking for is our get random responses method, and you can just hit enter. But before we hit enter, you may notice some other methods there that we didn't explicitly create. These methods are still accessible through our class. As a matter of fact, these methods are accessible through any class that you create in Java. Now the whole Java object-oriented idea comes from a generic class. So every single class in Java you can imagine is born out of a generic class called object. And inside of that generic class called object, we have these additional other methods available. Now you may not necessarily use these methods just yet, but when you get into more advanced Java, you'll be calling these methods on a regular. So we just hit enter and it generates that code for you. And you can imagine at this point in time, a random response will be returned and saved inside of the response variable here. And the next thing we need to do is just set it to the display. So we again use the same fashion and say display, and we have a whole bunch of methods that pop up for us. Now the display is of type JTextArea. Now that class has been around, so that class inherits from a lot of other classes. So you'll find a whole bunch of methods to go through. But the method that we're particularly interested in is the set text method. Alright? Sorry, not set action, not set text. Try that again. There it is. And it just takes a string as an argument, and the IDE automatically knows what you're gonna type in there, so it does that for you as well. So there's a lot of time that's being saved with the IDE. Alright, so once this is done, you can imagine that when this is called, we'll see a random response pop up on our display, which is our text area, which is also displayed inside of our frame. Alright, so let's run this now. Let's clean it again and run it again with this in place. You'll see this here. You click on the button and you should see a response, but nothing happens. Nothing happens because we haven't explicitly designed or coded the event listener for this button. And this is what we're going to do next, and that's going to be just about the last thing we're going to have to do to make this application work, just like we intended. Now, the best way that I can explain event listeners, and that's what they call them in Java, is to have you think about the onClick attribute in JavaScript, for instance, or in HTML and JavaScript. OnClick is like it's an event trigger as well, and it allows you to specify a particular method that should be called whenever the user clicks on an item or an element inside of the DOM. Alright, it's the same principle here with Java. Our button is the element that we'd like to respond to the click, and handle shake is the function, or the method rather in this case, that should be called whenever the button is clicked. The way we code it up in Java looks something like this. This is just one way of doing it. There's another more complex way. Not necessarily more complex. Yeah, in a sense it does involve a few extra lines of code, but this way it works perfectly fine, and as a matter of fact, in my opinion, it's easier to manage. So we do something like this. We use the reference of the item that should respond to an event, such as in this case our button, and we call the add action listener method. Now you're gonna notice some freaky coding going on right here, but just follow me. So this add action listener method takes an object as well, which represents the action event, and that action event object has within it a call to our handle shake. So the entire thing when put together looks something like this, and we're doing a lot of things at once here in Java. It should be action listener, not action event. Right. And inside of this method we put our call to handle shake. And we just right click and choose fix imports, and all that goes away. Alright, so just to explain what just happened here, this is just like calling the onClick, or just setting up the onClick in your HTML JavaScript web page, but it's a bit more complex than that since Java is particularly object oriented. So what's happening here is this add action listener method works something like the add method, but instead of a component that's being added, you're adding an actual listener object. Now this listener object is designed to respond to a particular event, which is called an action event, and whenever that event is triggered, this action perform method is called, which in turn calls anything else that you put inside of it. In this case we want to call our handle shake method. So with that being said, in summary, what we've done essentially is allowed our button to respond to a click, which would in turn trigger our handle shake. Okay, so let's see how that works. Alright, so what should happen right now when we click, we should see a random response show up, and we do. Ask again later. We can click again and we see another random response, yes, and so on and so forth, and we can do this as many times as we wish. Right, so we've just successfully programmed our very first Java application, abstracted from an actual real world object, and it doesn't look like much, but it's up to you to make it look a bit better. But the principles that we covered are foundational principles, and they're quite important for the remainder of the course and the remainder of your experience with object-oriented software development, as a matter of fact. Right, so just to recap everything, how that works is this class is instantiated by this class, alright, which is our entry point or driver class. Once this Magic 8-Ball, once this 8-ball frame class is instantiated, it in turn instantiates our display, which is of type JTextArea. That's how we show the user the response, as well as our randomizer, which is of type randomizer. And whenever the user clicks on this particular button, by virtue of this listener that's being registered, the handle shake method is called, and the handle shake method in turn calls the randomizer's get random responses method, which returns a single response that's random, and then it sets that response to the display, thereby rendering to the user a random response. So in essence, we've basically programmed the state and behavior of the real world object, the Magic 8-Ball, and we've turned that into an actual program using OO, decomposition, abstraction, and Java.